So just quickly, guys, it's good to see everybody. Last year and the years before, we did Science Day and then we did Family Day all together. This year, fortunately, Virginia and Catherine and Marcia and I had to have meetings with the Promise team, the clinicians and industry from about 7 a.m. to 1 p.m. So I'm tireder than usual, but this is a good problem to have because we've had a lot of industry meetings and collaboration today, and we're about to have more. This is a super important session, right? This is not a theoretical at all. I'm going to frame it up a little bit, and then we're going to hear from 3 companies who are or will be recruiting for trials. And the way we get better medicines is we take all this research that's been going on and we get it through a trial and we have a marketed drug. So our community participating in these trials is critical, absolutely critical. This is my favorite slide for those who don't know it. Do I have a laser pointer on here? Yeah. So Syngap was identified in 1998 by Rick Huganier, who you heard from yesterday. The first time we found it in a human was in 2009. Check your watches. That was 16 years ago. We have only had this disease in human beings for 16 years. And these 3 or 4 ladies in Canada that were found were incredibly severe because the most severe kids get tested first. At that point, we knew Syngap was a neurodevelopmental disorder. And then a few years later, Dr. Ingrid Scheffer and Dr. Heather Mefford, who were both on our scientific advisory board, wrote this paper about Syngap and CHD2. And in that paper, they said, actually, Syngap is not just a neurodevelopmental disorder, it is a developmental and epileptic encephalopathy, meaning these kids have seizures, and these seizures severely affect the development of the brain. That was in 2013, if my math is right. Tony was diagnosed in 2018. That's why it's my slide, so Tony gets to be on it. And we did a little paper about it, and then Ash and I, as you know, created what was then Syngap Research Fund, what is now Cure Syngap1. Dr. Ingrid Scheffer, who is like a global legend, wrote this paper that came out in 2019 with a huge team, and that was the first natural history study of Syngap1, about 57 patients. We were very lucky that that work was done right when SRF, now Cure Syngap1, started. The year after that, we started our partnership with Citizen, who's changed their logo like 5 times since then. But you should all be signed up for Citizen, right? That is the retrospective natural history study. So we have 2 natural history studies. We have Promise, which is prospective. You join it now, they collect your data going forward. We have Citizen, which is retrospective. It gets all your medical records and mops them up. There is no reason not that every US family should not be in Citizen. Don't consider it optional. It takes 10 minutes, it's helpful, and it creates valuable data for industry. We started that in 18, 19, 20. At the same time in 20, these 2 papers came out, Satterstrom and Fu. Well, one of them, Satterstrom came out and then Fu came out a couple years later. Those 2 papers said of all the monogenic causes of epilepsy, Syngap is top 3, right? These are hugely important papers to know about for 2 reasons. First of all, it triggered a lot of industry and philanthropic interest in Syngap1. But second of all, when you're arguing with your clinicians about an autism diagnosis, you need to break these papers out and be like, hey, big papers, you should know about these. But I'm getting off topic. A year later, we started with Rarebase. Rarebase has now transcribed to bio. We did this to do repurposed drugs. I don't have time to tell you about that story, but the mission was better drugs for our kids. The reason we're in this room is better drugs for our kids. The reason Kelly and David and Yuri are going to talk to us is better drugs for our kids. The mission is better drugs for our kids. How many families are in this room? I don't know, 50. How many families are in the US? 450. How many families are global? About 2,000. How many families are there out there who haven't even been diagnosed yet? Tens of thousands. How the hell are we going to help everybody? Detailed phone calls and hand-holding? Sending them checks and care packages? Funding their, no, better medicines. We need better drugs to help these kids. And that is our focus. And that is why I'm so damn focused on this. And that's all I've been focusing on for this whole time. Well, that's why we started with Rarebase. And that same year, we got this number, F78.A1. That's a critical number. Every clinician you see, I don't care if it's PT, OT, doctor, ped, whatever, if you're in the ER, be like, put F78.A1 in that medical record. That is your ICD code for Syngap1. And we need it in the medical record because that is how, I don't have time to tell you all the way, I've done like 3 podcasts on this, but we fought like hell for this code, and now we need to get it. Because then we're going to have a code, a diagnosis, so when we have a medicine that's specifically for SYNGAP1, maybe from our friends at Camp 4, there'll be an ICD code to put against it. La-di-da, I've lost track, 18, 19, 20, 21. In 23, Praxis, which is the company Kelly works for, and then Stoke Acadia announced that they were interested in and working on SYNGAP1. We also started working with Probably Genetic. I'm not going to talk more about that. The year after that, 2 really important things happened. The Penn grant happened. So as you know, the program at Penn and CHOP is funded by an anonymous grant to Penn and CHOP. So all the work that happens there, we do not pay for. All the work that happens everywhere else, we pretty much do pay for. So thank you to our donors. Without our money, somebody said to me yesterday, somebody in this room, they were like, we're just so lucky they're working on SYNGAP1. I'm like, well, someone's got to pay for it. And they're like, yeah, but they still have to want to work on SYNGAP1. Let me tell you guys, a lot of people want to work on SYNGAP1. But if we're not paying for their postdocs, there's a lot of other people who'd be willing to pay their postdocs to work on their disease. So at the end of the day, money talks and you know the rest. But it was those few short years ago that Praxis and Stoke said, we're interested in working on SYNGAP1. And that was a big day. That was a big year. This was the first time a biotech said they were working on SYNGAP1. So I'm always grateful to Stoke and Praxis for helping put us on the map that year. Year after that, we did drug repurposing with Clement Chow. That's where Nal came from. Penn got announced. And only last year, we also worked with Unravel. I don't know if Richard's in the room. This was a big year last year. 3 things happened. This paper from Epilepsia came out. This was 150 patients. This was the Wiltrout paper. This paper is entirely based on data that came from Citizen. 100%. All of the data in that paper came from Citizen, which we set up, right? So this was, the number of patients involved in the neurology natural history study was 57. This was 140. There we go. And only last year, Camp 4 announced. This year, we changed our name to Cure SYNGAP1. Gondola Bio announced, and here we are. So just important context, right? Right now, it feels like, what the hell's going on? Why is this my life? But if you step back for a second, guys, we are still the tip of the spear. This is the very beginning. This disease has only been in humans for, I'm really tired, 16 years. And here we are pounding the table, demanding better medicines, wearing these fabulous green t-shirts. And we're about to hear from 3 companies, all publicly traded, who are hiring incredibly talented people and working around the clock to create better medicines for our kids. But we cannot get those better medicines into our kids unless we learn about the clinical trials and jump in. So that is a long wind up. Oh, so I'll be quick. I'm not going to talk through everything, don't worry. These are all the drugs we are tracking. There are small molecules, which are pills that I'll let Kelly and David talk about small molecules. And then there are precision therapies, which like ASOs and AAVs, which Yuri will explain. But these are all the medicines that are out there. And what you're seeing here is, you start in the lab, and then you stick it in mice or other animals, and then you go to human trials. There are a number of purple lines in the human trials. Bexicaserin and relutrigine are the 2 molecules we'll be talking about today from Praxis and from Lundbeck, right? This is normally how it's done. And then soon, we're going to go to precision therapies. And the first green arrow that's likely to cross this line is Camp 4. When Cure SYNGAP1 started 7 years ago, this slide was blank. Everything that's got a Cure SYNGAP1 logo next to it, we've directly funded in some way. Everything else, we've just begged, bothered, harassed, done whatever it took to get them on this slide. And all of it comes down to clinical trials. So I want you to really welcome and listen carefully to these next 3 speakers. They're good people. They're working like crazy. And then think of it as a caregiver. Do I want my loved one in this trial? Think of it as a member of this community. Wow, this trial's not for my kid for whatever reason, but I know another parent who needs to know about this. And think about this over time. Maybe it's not for you today, maybe you're not the right age, or not the right seizure phenotype, but as we know with this disease, things change. But every one of you who had it together enough to get into this room is a leader in our community. And you guys need to go back to your state, to the Facebook group, to wherever you go and talk, and encourage other people in. And as you're going to hear, and then I'll promise I'll let you speak. As you're going to hear from Long Board and Praxis, these are not SYNGAP specific, these are for DEEs. So maybe you know someone with Rett, maybe you know someone with CDKL5, maybe someone, you pick a disease. Make sure they know about these molecules too. It's incredibly exciting stuff.